Applications of electrolysis, which is certain as use of electrolysis. So number one, extraction of elements. So metals, some highly electrolytic metals like sodium, potassium, magnesium, aluminium are extracted by electrolysis. And some non-metals like oxygen in electrolysis of acidified water, hydrogen, electrolysis of acidified water, hydrogen, oxygen, chlorine. So these are some of the non-metals that have been extracted by electrolysis. Purification of metals like copper, mercury, silver, and gold. If you look at all those metals below hydrogen electrochemical series. Okay, so these metals they occur as ores. So what is ore? Ore is a naturally occurring compound found in the earth. So they come with impurities, which must need to be purified. Okay, number three is electroplating. What's electroplating? It means coating one metal by another. So if it's zinc that's being used to coat another metal, we'll call it galvanizing. That's galvanization. So number four is preparation of some important compounds such as sodium hydroxide. Commercial production of sodium hydroxide is prepared using electrolysis of brine. Extraction and purification of metals, highly electroplating metals like sodium, potassium, calcium, magnesium, aluminium, they occur as compounds in the natural ores. So what is ore? Ore is a naturally occurring compound found in earth. So they need to be purified before extraction. So for example, sodium is extracted by electrolysis of molten sodium chloride. Molten sodium chloride. So when sodium is melted, heated at temperature of 801, it melts, but does not decompose. It melts, and the ions become mobile. So the sodium ion will migrate to the cathode and become discharged as metallic sodium. Chloride ion will migrate to the anode and become discharged as chlorine gas. So the same goes for calcium chloride. Fused calcium chloride. So there's no effect of no competition with the ion coming from solvent. So this one will migrate to the cathode. This migrate to the cathode and become discharged as calcium. White chloride ion will migrate to the anode and become discharged as chlorine gas. The less electroplated metals like copper, mercury, silver, and gold tends to occur in uncombined form in ores, and ores are usually contaminated with sand, limestone, and iron compounds. Okay, let's look at how purification of extraction and purification of copper from copper ores. Let's look at extraction and purification of copper from copper ores. The same goes with purification of mercury from mercury ores, purification of silver from silver ores, purification of gold from gold ores. So extraction of copper from copper ores. The electrolyte is any soluble salt of copper. So it could be copper 2 tetraoxide of a 6 solution, SO4 aqueous, or it could be copper 2 chloride, copper 2 triazonite 5, any soluble salt of copper 2 ion. Okay, this is the electrode. So the cathode is the pure copper. The pure copper is made the what? It's made the cathode. It could be copper plate, copper rod. It's made the cathode. The impure ore is the anode. So what happens is that copper in this ore is going to dissolve in the solution to form copper 2 ion. So that's what happens at the anode. At the anode. So the copper metal from the ore will dissolve in the solution to form copper 2 ion. That's oxidation. We give up its electron to form copper 2 ion. So this is copper So what happens at the cathode? The copper 2 ion in the solution will migrate to the cathode, where it accepts electron from the cathode and become deposited as copper on the cathode. This one will continue like that. The copper from the anode will dissolve in the solution to form copper 2 ion. That copper 2 ion will also migrate to the cathode, where it accepts electron and become deposited as what? As metallic copper. So here you see impurities. At the end of everything, those impurities in the ore, like sand, carbonate 4, will settle down. Will settle here. So what happened to the mass? Let me write the one at the cathode. So at the cathode, the copper 2 ion in the solution will accept 2 electrons from the cathode and become deposited as what? Copper. So what happens to the solution? What happens to the mass of the cathode and the anode? Since the copper in this ore will dissolve in the solution, so this mass will begin to do what? Decrease. The anode will begin to decrease in size, whereas the cathode will begin to do what? Increase in size. So at the end of the electrolysis, there will be increase in mass of the cathode because copper is deposited there. So the size is an question. So take note of that, very important. So the size of cathode will increase at the end of what? The reaction, while the size of anode is going to do what? Decrease. So what happens to the solution? Copper 2 doesn't have a cis, is blue in color. So what makes that contribute to that color is what? The copper 2 ion is present in the solution that makes that color the blue color you're seeing. So what happens to the color of the electrolyte? The color will remain the same. Why? Because the copper 2 ion, the copper from the anode goes into solution to form copper 2 ion. And the copper 2 ion.
Okay, let's look at analysis of electrolysis. So, analysis of electrolysis is electroplating. What's electroplating? Electroplating is the method or process of coating the surface of one metal with another, such as copper, silver, nickel, chromium, gold, silver, by means of electrolysis. So why do we electroplate? It's for protection, to protect the metal against corrosion and for decoration. Articles which are usually plated include tableware, cutlery, that's spoon, knife, jewelry, iron objects such as metallic parts of vehicle. So when it comes to electroplating, the setup for electroplating is the same with that of extraction and purification of metal. So in electroplating, the cathode is the object to be plated or coated. For example, I have iron spoon and I want to coat it with silver. So that iron spoon should be made the cathode, is the cathode. The plating metal, remember iron spoon, I want to coat it with silver. I want to silver plate it. The iron spoon, I will make it the cathode, it will be the cathode. The plating metal is the silver. So the plating metal is the anode, it's made the anode. What is electrolyte? Electrolyte is the soluble salt of the plating metal. So in this case, soluble salt of the silver. If it's gold plating I want to do, the electrolyte will be soluble salt of gold. Let's get an example of electroplating. So this is silver plating. I want to silver plate a spoon. So the spoon could be iron spoon, it could be copper spoon. But what you want to do is to do what is silver coat it. You want to go to silver. So like I said before, the spoon is the object to be coated with silver. So the spoon is the cathode, it's made a cathode. Silver is the plating metal, is the silver. So you can see this silver anode. So this silver could be silver rod, it could be silver plate. Then electrolyte is the soluble salt of silver. Remember, silver chloride is not soluble. Silver carbonate 4 is not soluble. So the soluble salt of silver is silver triose nitrate 5 solution If you're using formula to write, you have to put aqueous. If you not put aqueous, it will be wrong. If you just write AgNO3 like that, without putting aqueous, it's wrong. So the electrolyte is silver 2035 solution. So another part you need to notice what electron flow of electron. You must indicate it. So remember, electron enters the electrolyte through the cathode. You must always indicate it. So what happens is that current is passed through the cell. The plating metal, which is the silver rod, will dissolve gradually into the solution. By doing so, it's giving up its electron to form silver ion. So the silver ion in the solution will migrate to the cathode and accept electron from the cathode and become deposited as silver on the surface of this spoon. It will continue like that, until you start the process. So which means the thickness of the spoon that you want depends on the duration of the process and the magnitude of the current that is passed. The one you pass for 30 minutes, you stop. And the one of 3 hours, the thickness of 3 hours duration will be higher, will be thicker than that of what? That of 1 hour. So let's add the equation at the anode. The equation at the anode. At the anode, what happens at the anode? So the silver metal goes into solution to form silver ion. At the cathode, what happens at the cathode? Remember, at the anode, oxidation takes place at the anode. You can see the oxidation number of a silver from 0 to +1. So at the cathode, the silver ion will go to the cathode, which is the spoon, and give up its electron and become deposited. So this is silver ion accepting the electron to form metallic silver. So let's go to know how to write the equation for the reaction. Okay, so you can see this diagram, this layer of deposited silver. That silver that is deposited on the surface, that's the layer of to be on the surface of the spoon. So what if, okay, in this case, what if, for example, you are given in exam, you are asked to draw a setup that's used to plate a copper spoon with gold. Copper spoon with gold. So here, or copper knife, you just put it here. You draw your knife as the cathode. Then gold rod, put it here. The electrolyte will not be what? Soluble salt of gold. Right, put the electron flow. Start something there.